In this video we'll be taking a look at a transit pass system that I built using Redis, some Raspberry Pis, smart card readers and some LEDs in order to learn about the Redis Labs cloud service for the Redis database and message broker. Let's take a look at the architecture of what we're building. So up the top is a Redis database and message broker that's used for storing all the data, and it's the only way that the other components can talk to each other. That's hosted in the cloud on Redis Labs. It's actually on Amazon AWS, but other options are available. And over on the left we have a sales terminal component that's going to handle the issuing of passes to transit cards, record those in the database, from which the entry gate component can then make sure that tickets or smart cards entering the system have a valid pass associated with them. Both of those components are going to send pub/sub messages as well as update the database, and those pub/sub messages will be picked up by the system monitor over on the right, which is going to be a component that just logs those, but could, for example, put them in another database or send them onto other systems. Here's a quick look at the hardware components of the Redis powered transit pass demo. Over here we have the system entry gate. This controls whether or not you gain access to the transit system. So imagine it was connected to some sort of barrier gate. It has lights that are attached to the GPIO. Those will show red normally, and then you present a card to the card reader here. If you have a valid pass associated with that card in Redis, the lights are going to go green and you're going to hear a noise and it's going to let you in. If you do the same and you do not have a valid pass associated with it, the lights will flash red and you'll hear a buzzer noise and you wouldn't be allowed into the system. So this shares a Redis database with this guy here, which is the sales terminal. This essentially writes records to the Redis database. You present a card here to the card reader to begin a transaction. You press which one of 3 types of ticket you want to buy. We have a 1 trip that can be used precisely once and then it expires. 10 trip, so you can take 10 trips over any time period. And a 2 hour, which is once you've first started to use it, it sets an expiry in Redis, and after 2 hours that transit pass has gone, but in the 2 hours you can use it as often as you like. This component is also a Raspberry Pi using the same card reader, some arcade buttons here that have been wired into the back of the Pi and through this foam board, and then the Pi has been extremely professionally gaffer taped to a USPS flat rate box, which are great for these projects. Sound for both components comes from a Jawbone Jambox that's just connected via the headphone cables to the Pis. There is a third component to this. These two will both send pub/sub messages through Redis, and those will be picked up by a system monitor component. The software in these two components is Python. The software in the system monitor component, which is purely software, it has no hardware representation, is a Node.js module that just outputs the contents of the messages it received. So here we have the completed sales terminal part of the system. It has a button for each type of pass that we might want to buy, a card reader that we can tap our card to begin and end the transaction, and a speaker which will speak samples of my voice because there's no screen here, so you need some sort of user prompt. In the background we have text output from this component, so it'll be able to show us what it was doing. We have an initially empty Redis database, and we have the system monitor component running. So what will happen is as we add passes, the sales component will add those values in Redis. It will also send a pub/sub message which will be picked up by the system monitor. So let's try it out. So card number 1 here we're going to leave intentionally blank for now. Card number 2, let's buy a single use pass.
Now press the button for the pass that you'd like to buy. Tap your card again to confirm your purchase. Thank you, you bought a new single trip pass.
So what we see here is the output of the sales terminal. We bought the pass and we press the buttons. we see that the sales terminal told the system monitor via pub/sub that a single pass was bought. And if we look over here in the Redis commander, we should now have a value in there, and it tells us that that card bought a single use pass which doesn't have an expiry date. So let's go and buy some more. So for card 3 here, we want to put the 10 trip pass on that.
Now press the button for the pass that you'd like to buy. Tap your card again to confirm your purchase. Thank you, you bought a new 10 trip pass.
Then finally with card 4, let's use the 2-hour pass.
Now press the button for the pass that you'd like to buy. Tap your card again to confirm your purchase. Thank you, you bought a new 2-hour pass.
And we see here the pub/sub messages were sent to the system monitor, and if we look at the Redis commander here and refresh it, we'll see that we now have a 10 trip with unlimited time to live. We have the single use with unlimited time to live, and we have the 2-hour pass, which also has currently unlimited time to live because the 2 hours starts on first use, which will be handled by the entry gate component. So this component also has some smarts built into it. If we were to try and buy a pass with card 2, it already has a pass on, so it's going to reject that.
This card already has a valid pass. This transaction will be cancelled.
And if we try and buy a pass with card 1, but we walk away partway through and then someone else comes along, it'll also get rejected.
Now press the button for the pass that you'd like to buy. Tap your card again to confirm your purchase.
So the user of card 1 has walked away, something's gone wrong, they didn't have any money or whatever. The next person comes along.
The card you tapped doesn't match. This transaction will be cancelled.
And we cancelled out the transaction with nothing written to the database. Here we can see the entry gate component, which has a card reader attached to a Raspberry Pi, which has LED lights on it that's going to show whether we allow them into the system or not. And then connected to the audio connection at the back here is a Jawbone Jambox that we'll use to play some sounds, a buzzer if they're not allowed in, and a welcoming chime if they are. Up here we can see that we have the output of the Pi, so we can get a visual on what's going on, and we have the system monitor over there, so we can see the results of the entry gate sending in information to the wider system monitoring component. So let's have a try at presenting a card. So I have a card here that has currently no pass associated with it. So if we present this one, it should be rejected by the system. The light should go flashing red, and we should hear the warning buzzer and some output up here. So as we see, we were denied entrance. The system here said, no, we're not allowed. That card has no pass associated with it. And it sent a message to the system control that says, hey, we tried to get into the system illegally. So let's do that again, but with a single use pass. So this card here, number 2, has a single use pass associated with it. This time we get a more welcoming noise and the lights have gone green and we're in, and now it's gone red, we're ready for the next person. So the output here shows that we went green and then red again. And over here we can see that we tried to start a valid journey and we were allowed because we had a pass. So this time this card was let in. Doing that again with a 10 use pass. So card 3 here has a 10 use pass loaded up on it. Again, we're allowed in, things go green. Difference this time is the system says, hey, we have 9 more trips on that pass. And over here, system control has been told that we have 9 more trips. If we do it again, down to 8, and so on. Then finally, we have the 2-hour pass. So card number 4 here, which just fell on the floor, has a 2-hour pass associated with it. If we hit this one, That's our first time using that 2-hour pass. So what we can see here, if we move this guy up a bit, is that the 2-hour pass was used for the first time. So we started to set the 2-hour countdown on that, and it led us into the system. Over here, system control, same thing, 2-hour pass was activated for the first time and it started a journey. So what we should expect if we do this again with number 4, the 2-hour pass, is that it starts the journey, tells us how long we've got left on the pass and lets us into the system. And over here, system control this time was just told we started a journey. There was no need to reactivate the pass as we already had it going. We've done that little experiment with the 4 cards. We can open up the Redis commander here and have a look at the state of our remote Redis in the cloud. We can see there's 2 keys left because we originally had 4 cards, but one of them never had a pass on it in the first place, so that never had a key in the database. The second one was a single use card, so that was wiped out of the database when we used it because it only had 1 use, which leaves 2. So if we look at the first one here, this is a 10 trip pass, and as we can see it has 8 trips remaining in the database and it has -1 time to live, so there's no TTL on that, it won't get deleted, which leaves the second key, which was our 2-hour pass. The only information in the database here is that the pass type is a 2-hour, and you'll note that we have a time to live here which is ticking down, and after 2 hours that pass will get automatically deleted from the database.
2 hours later, 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 2 hours later.
Passed, and we can see that in Redis commander, Redis has expired the key for the 2-hour pass, so the only one remaining now is that 10 trip ticket that we had. So if I get card number 4 and we try and present the 2-hour pass to the system again, what we'll notice is that it gets denied as it no longer exists. So as we can see, this is now treated like any other card without a pass on it. The pass has auto expired and the owner of this card needs to go buy a new one before they're allowed access to the system again. We're now looking at the system monitor component. This doesn't have a physical manifestation like the other 2 components. It's pure software. It's written in Node.js and you can start it easily with npm start of package.json, has the script in there. What it's going to do is listen on a bunch of pub/sub channels and print out messages that come in. It's going to use the popular chalk package to show these in a different color depending on what's going on with the system. So if I go ahead and in another terminal add some cards to the system by buying passes for them, we'll add a card 0000 and I'll give it a single trip pass. And what we'll see is the sales terminal sent a message out saying 0000 bought a single trip pass, and the system monitor here picked that up. If we try some other things, such as an invalid system entry, we'll see messages in red for that, for example. You'll hear the entry gate, and the entry gate sent a message, and the system monitor here picked up on that and is showing it red. So if I go ahead and add, for example, a single use pass to a card, so you see I've just added a card that has a single use pass. If I now try using that card, the system monitor will pick up on that as a acceptable use of the system, appears in blue. And if I try using it again, system monitor will pick up on that as an unacceptable use of the system, as it was a single use pass and we've already used it the once. And that's the end of our tour of the Raspberry Pi Redis transit system. If you're interested in seeing the source code, check out the GitHub link, and if you'd like to read more, check me out on Medium. Thanks for watching.